Welcome to this introductory video series on topology. You might recognize the term topology from popular videos online where you'll often see that a donut is the same as a mug due to their shared topological properties. Today, though, we'll start with some foundational concepts to help us understand this rich area of mathematics, beginning with metric spaces. What is a metric space? Let's start by defining a set, which we'll call X. A metric on this set X is a function that assigns a real number, representing the distance to every pair of elements from X. For this function to qualify as a metric, it must satisfy three specific properties. Identity of indiscernibles. The distance between two elements is zero if, and only if, both elements are exactly the same. Symmetry. The distance between one element and another is the same as the distance when measured in the reverse direction. This property is known as symmetry. Triangle inequality. For any three elements in X, say one element is called X, the other Y, and the third one Z. The distance from X to Z is always less than or equal to the sum of the distance from X to Y plus the distance from Y to Z. This property is called the triangle inequality and is illustrated in the following diagram. With these definitions in place, let's try our first proof. We want to prove that the distance between any two elements in X is always greater than or equal to zero. First, observe that the distance from any element to itself is zero. Then, by using the triangle inequality, we find that the distance from X to Y is less than or equal to the distance from X to Y plus the distance from Y to X, which simply reduces to 2 times the distance from X to Y. This means the distance from X to Y is always greater than or equal to zero. This completes the proof. Let's define metric spaces. A metric space is a pair, often written as X and D, where X is a set and D is a metric defined on X. Sometimes we refer to the metric D alone, assuming the set X is clear from context. Let's look at a few examples of metric spaces. We can define a metric on the set of real numbers and complex numbers by stating that the distance between two numbers X and Y is given by the absolute value of X minus Y. Let's check that this definition satisfies all metric conditions. Identity. If X equals Y, then the absolute value of X minus Y is 0. Conversely, if the absolute value of X minus Y is 0, then X must equal Y. Symmetry. The absolute value of X minus Y is always equal to the absolute value of Y minus X, so symmetry holds. Triangle. Inequality. We know that the distance between X and Z is given by the absolute value of their difference. By adding 0, a common trick in mathematics, we can apply the triangle inequality and complete the proof. Another example is the trivial metric. On any set X, we can define a metric where the distance between two elements is 0 if they are the same and 1 if they are different. You can check yourself that this satisfies all the metric properties. This concludes our introduction to metric spaces, a foundational concept in topology. In the next video, we'll build on this understanding to explore topological spaces in more detail.